Okay, so if we're coding data, so you might get some ugly data, something like this. I don't remember if I made this up or not, but we'll have a year, and maybe chocolate bars sold. In 89, like I said, I don't remember if I made this up, but I'm pretty sure the data's probably a little bit later in there. There's probably if you do 85 million chocolate bars a year, so. What? Okay. Yep. Bad timing for talking about food. Great at snack time, huh? This might have been just 1 month. That's probably what it is. Oh, okay. Yep. Now I get it. Valentine's Day over. That makes more sense now. Yeah, I'm awake and I'm here. Okay, so there's our data. Big, ugly numbers, right? No. We're just becoming more health conscious. Yeah, right. Not in my experience.
Yeah.
I work in high school. We are not becoming more health conscious. I'll have 5 cookies and a brownie for lunch. Yes, thank you very much. I see that whole other thing. Of course, you guys probably see it more than me, because I don't hang out in the cafeteria. Okay, let's make this easier. So let's code the data. A great way to deal with date for years is years since. And your first one is 0. Well, easier than 1989 to work with, huh? When you do your equation, it's going to make your life easier. What's 94 then? Five. So we have a 5, and we have 10, and we have 15, and 20. A little nicer, right? And then chocolate bars in millions. So we would have 5, 4.5, 3.5, 3. You write left-handed. That's right. Oh, good time to practice.
It's horrible. It's all over.
Practice.
I'm trying.
No, you're not. You're sitting there.
Practice.
So you see how that got coded? You good with that? What? I have people sometimes. You okay with coding data there?
I can't.
Now it's just the same as we've been doing. So let's draw a scatter plot.
Oh.
Remember, we always put time on the x-axis unless we have some reason not to. Okay, title and labels, right? And the nice thing now, all we have to do is go from 0 to 20. So for 0 to 20 years there on our coded data. And then from here we can just do zero 5. So a scatter plot. Go ahead and draw a line at best fit there if you are known scatter plot. Well, I'm only giving you 1 or 2 a night. You get better at it with practice. Okay, draw a line at best fit there. I do have rulers. Anybody want a ruler?
I was curious.
So I'm gonna go somewhere like that.
Take your first three points.
That looks about right. Alright, so that's our basic structural work. What's the y-intercept on my line? Okay, so the y-intercept is 5. Okay, explain that meaning in context of the problem. This is where the rubber hits the road. Can you use your math? Explain what 5 means. Yeah, that's good. No. Okay, now when I say explain in context, I mean, what does that mean about years and chocolate bars sold? 1 year.
1989 was 5 million.
What year is 0?
$89.
Okay, so, yeah, 5 million chocolate bars were sold. Valentine's Day, 1989. That is explaining in context. That's what that means. Explain meaning context. You'll see that today, tomorrow, on the test for the rest of the year. And you take the numbers, use them. Okay. Kind of like, how much airflow does a turbo put into a motor? Anybody got any numbers there? Cubic feet per minute or pounds per square inch? PSI, so 10 PSI, what does that mean? Bigger the number, the better, right? And pretty boring about that. That's explaining your meaning in context, right? Alright, what's the slope here? Hey, I'm not going to calculate the slope, you are. This is practice for you. And I'm going to call on somebody to give me the answer. We calculate the slope of this line. Nobody say the answer. Oh, yeah. It's really easy, but you'll end up with practice. Random here. Got it. You got it? Maybe 20 more seconds. Ish. Luke, you have an answer? Get it done.
Anybody want to volunteer answer? Thank you, Brandon.
Yeah.
I got 1.5 over 1.
Is that all right? Negative 0.15,
Oh, yes, yeah.
we just put it in fraction form. So remember, we can use our coded points, 0, 5, and what's this one? 5, 4.5. Okay. You could also use this other point because that goes through there as well. Doesn't matter, you get the same answer. So, 4.5 minus 5, and 5 minus 0. So might actually get negative 0.1. Okay. You can use different points to get a slightly different slope, but they're close enough, right? Because this is a model and it's an approximation. Okay, so what's our equation? You can use point slope or slope intercept. I mean, these two numbers, y equals what? Okay, good enough. Now, I know we've been practicing all that math, so you're probably getting pretty good at it. Explain the meaning of the slope in the context of the problem.
It's been a half a year since, or and a half year, I made something like that.
Yeah, the units reversed. The y is on top. So we have chocolate bars decreasing by 0.1 million, right, or 100,000, either one, every year. Right, so you always have the y's over the x's. So
But that's for between 15 and 20 years. So that negative amount to be.
that's why the model is not quite perfect. Yeah.
I'm saying, if it was perfect, that negative one would come out to be like 100,000 chocolate bars. Like exactly 5 years. Right, something like that.
Right. So you get a 0.1 million decrease in chocolate sales per year, or 100,000 fewer chocolate bars are sold every year, something of that nature. Okay. You're just showing the decrease or the increase of the rate of change. All right? One more item. Predict 2014 sales. We're not done yet. We'll be done. Okay. About 3 minutes. I do like the water drinking now. Right? The sheet goes. Okay, so predict 2014 sales. Where are we at? How do we do that?
You would first find how many years it is. 25.
Okay, 25 and
Put it on the map and then you just underline that's it.
you can do it graphically, right? 22, 24, 25. What do we think? A little between 1 and 2 million, so 1.75. Graph. About 1.75 million. See how we did that? And then what about our equation? We can throw that in there for x, because that's what x is, year, right? And then we get 2.5 million. You can see that we're a bit different there. For some reason. So again, explaining in context.
Did you get 2.5 and 6.5?
Yeah. For the equation. The graph's a bit different.
My graph is 2.5.
Yeah, so bear in mind then. Any questions? It's too easy for you? I really guess.
I just think we should get started. I think it would be good.
Like I said, I know you can do the math, I've seen it.
Just take,
It does take time and you have to be able to explain it, so. Okay, again, I give you the rest of the hour, we've got 20 minutes, so that if you have questions, those can get answered. If you get stuck, please say something. All righty?